How are these decals and sticker alike? Hayden. Okay. Micah? They have the same design. Anything more specific than the design? I want you to pay attention to like the trapezoid-ish thing. Daniel?
The same shape.
They are the same shape. However, how are they different? They are different in size. What do we call something that is the same shape but different size? Oh, well, that's where we're going with this, but I was looking for a different word.
Mini. Enlargement.
Starts with an S.
Shape.
They're not the same, but they are similar. Okay? So in this chapter, the whole point of this chapter is we are going to talk about similar figures. Now, lucky for you, this chapter in this book starts out with dilations. You know what a dilation is, okay? But what we can connect, okay, we are now talking about, okay, we know that a dilation takes a shape and stretches it or shrinks it, right? Somebody said enlargement, okay? You might have said reduction in one of your conversations, okay? Our beginning and ending result, those are similar figures, and that's this whole chapter that we're going to do this week and next week, okay? So, I want you to turn the page. I gave you a ruler. Why did I give you a ruler? Okay, so we're actually going to create a dilation with our ruler. And I have no idea if I have a ruler or not. Yeah, I do. Okay. All right. What if I want, okay. So, this, what? I'm trying here, guys. I've never used this. Okay, so I am going to put my ruler. I'm going to put the start of it here on R. Oh, you can't see it. What? Oh, now you can see it. Okay, here's my ruler. Do you see it? Okay, so I'm going to put my ruler. It starts on R, and I'm going to put it here on J. If I want to dilate this triangle with a scale factor of 3, first of all, is our triangle going to get bigger or smaller? Bigger times 3, right? So it looks like, you see these tick marks in our inch, okay? 1, 2, 3, 4, 5, 6. So it's like 6 of those tick marks, right? So if I want to triple it, how many tick marks do I need to go? 18. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
Ours is like
Okay, so mine have 1/8 of an inches marked.
You have 16. It's
like you have 16.
It's like 3/4 of an inch, pretty much.
It's
make it 12.
okay, so if it's 3/4 of an inch, if we triple that,
9/4.
we would have 9/4 of an inch.
2 1/4.
2 inches.
2 1/4. Okay, or maybe you want to use the centimeter side. I wish I knew how to make this into centimeters. What? Okay, so then what I'm going to do, I'm going to put it at R. and I'm going to measure R to L. Okay, I'm going to measure that distance, and then I'm going to triple it. Okay, so maybe you want to use the centimeter side. I don't know how to make this in a centimeter, so I'm going to use the inches side. Okay, so mine is 7/8 of an inch. So if I triple 7/8, I would have 21/8. So 8. So there's my new L. Okay, then we're going to do the same thing with R to K. Oh, what? You turkey. My ruler is showing me. I'm on the inches side, and it looks like it's 3/8 of an inch. So if it's 3/8 of an inch, and we need to triple it, how many eighths is that?
9/8.
All right, so I need to measure 9/8. So I'm showing the orange lines where we measured, okay? First we measured the purple, and then we extended the orange based on what we needed to measure, okay? So we've dilated this by 3. So you didn't get to do this in our last one, right? What? Right now it's 11:17. 11:30. Hayden is just counting down the minutes. Okay. All right. Now, I want to give you time here in like 10 minutes to be able to do the one problem in your homework you would need to use the ruler for. So what I'm going to do, I'm going to skip part B, and we're going to go to the next page. Please, everybody, put their rulers off to the side. Okay. Okay. So I would like you to look at example 2. We have rectangle WXYZ, and then we have the dilation of WXYZ. What I want you to talk about with your new elbow partner, how are the side lengths and angle measures of the two figures related? You have 30 seconds, go.
They're 3 times bigger. That's a third less. Well, very small. Third.
All right, so what do we think? Okay, so it's 3 times smaller. So K would equal 1/3. I love that. Yeah. Okay, good. Now let's talk about number 3. First of all, how do we know whether it's an enlargement or a reduction? Lucas? Okay, so is this an enlargement or reduction? Reduction. It's a reduction because the A prime, B prime, C prime is smaller. And if it's a reduction, we know our scale factor is less than 1. Specifically for this example, what is it going to be? 1/2. We've got this, don't we? We've got this. Okay. Now let's go to the next page, okay?
So is negative scale factor reduction?
So our scale factors are always going to be positive numbers. So a positive number less than 1. Thank you for that, Alex. Okay. All right. Now, the reason I wanted to do this section again, even though we've already seen it, our notation is a little bit different. What do you think this means? Dilation of 1/4. So this guy right here, its coordinate is -4, 0. Where's the new one going to be? Its new one is going to be at -1, 0. This guy right here, P, is 8, 4. Where's P prime going to be? 2, 1. Okay. And Q is, what is that? 12, -4. So it's going to become what? 3, -1. We have tissues on the way, bud. So there's our dilation. Okay? Okay. Now, algebraically, this is the notation we're used to. X comma y gets mapped to 1/4 times x and 1/4 times y. We saw that notation last time, didn't we? Yeah. Maybe a little bit? Okay. Okay, now, what is true about the distance from the origin to each of these red coordinates compared to the distance from the origin to each of the blue coordinates? By? It's 1/4 the distance, right? That's the whole point of what we're doing. From the origin, we're changing that distance, okay? All right, now, we're going to skip number 5. We're going to skip number 5, okay? Because I only ever want you to dilate about the origin, and this guy's asking you to dilate about A. We're not going to do that, okay? So, hey, that's just one less thing for us to do. So let's look at number 6. I think this is a really great problem. Population density. Mott County is a rectangular region with dimensions 39 by 48 miles. The town of Westville is a dilation of the county with a scale factor of 1/2. Okay, so what should we do next? I think we should talk about what Westville County looks like, don't you? If Westville is a dilation with a scale factor of 1/2, what's the width of the triangle? That's not a triangle.
24. Can I go and ask someone else to use?
Yeah, let me go to the bathroom, use the toilet paper, okay? 24? And what about the other side? 19.5? Okay. Population density. What the heck does that mean? People per, people per,
Square mile.
oh, people per square miles. So I need how many people over the number of square miles? Okay, how do we find square miles? I know that there's 84,106 people. Logan, how do we do it? Don't I what?
My mind is.
How do I find the square miles? Lucas? Oh, we find area by taking width times height. So somebody, I heard the calculator come out of somebody's backpack. Could somebody take 19.5 times 24?
What?
19.5 times 24.
468.
Wait, I was actually close.
468.
468? Yeah.
No, it is.
Okay. So now I want you to take 84,106.
It's 42,053.
No.
Not what?
No.
Nope. If I take 84,106 and divide that by 468,
179.71.
okay, but if I'm talking about people per square miles,
180.
so 180 people per square mile.
Look at something.
Okay. Okay. So I'm going to ask that you do page 166, but only 1 through 7. You're going to need your ruler for number 5. So I'm going to encourage you to do number 5 right now so that you don't have to use a ruler outside of the classroom. Okay?